Alright everyone, here's the first stats lesson of the year. We're going to do graphs of categorical data. Okay, so let's say that we are asked, what is your favorite cable channel? And we're asked to at least look at a pie chart. We'll make a small one here. And so ESPN had 62 votes, HBO at 30, CNN at 21, and 37 said some other channel other than the three that are listed here. And that's a total of 150 people. So in order to get a solid pie chart, we need the percentages. So in order to get the percentage, all we're going to do is 62 divided by 150 and do the same thing for all of the numbers. That's 0.413, so we got 41.3%. So for 30, we got 20%. For 21, we have 14%. And for the last one, we have 24.7%. So in a pie chart, start out with our circle. And ESPN is 41.3. So we're going to bring the number down to the middle. And I'm going to try to make this about 41% of my circle. So a little bit less than half. And the thing about pie charts is we have to use all of this circle, so we have to include all four of these choices. That's 20%, that's HBO, and CNN's a little bit smaller, and here we have other to be about 25%. Never ask you to actually make one of these by hand. However, this is the process upon making them so that at least you'll be able to read them. So looking at this, you can tell that ESPN is larger than HBO and CNN. Other is bigger than CNN. Other and HBO, we'd probably need to look at the numbers just to make sure. Based on my picture, other is a little bit bigger, but my graph's not perfect. All right, let's say that we're asked for now a bar graph for ESPN and CNN. And the nice thing about bar graphs is if we don't have to include HBO and the other, we don't have to. It's okay. Now, one thing I want to mention is that a lot of people get away with scaling their graph a little bit. So you may see a graph on a news show or on a paper that may not be accurate because they didn't make the scaling up to size. So ESPN had 62. Went a little bit higher there, but and CNN had 21. That one was a little bit bigger than it should have been too, but you get the idea. And so the key thing about this, when you're doing a bar graph, is that you don't want these two bars to actually be touching. That will be for something else that we're going to learn tomorrow. But basically, whenever we're doing descriptives, we want some separation in between the two things that we're talking about, or the four things we're talking about. But that's basically a bar graph. We also could have used percentages, but we want to make sure we label the axes. So here is TV station. And over here we have number of people who chose. Now we also could have made that percentages if we want to use the percentages that were on the last page, but because we're just comparing how many, this was okay. Alright, one other thing before we move on to the leaf plots, we have a simple question. Do you watch HBO? Of the men who were surveyed, 40% said yes. Of the women who were surveyed, 35% said yes. And down here we have men and women. So I should label this as gender. And let me just do 20 and 40 and 0. there's my bar graphs. These should be a little bit higher, and the men should be a little bit higher, and the women didn't. They should have been the same thickness. So, but is it okay that this doesn't add up to be? This right here adds up to be 75%, not 100%. But that's okay because the question wasn't saying this percentage of the people who watch HBO. It was 40% of the people who watch HBO is men, and 35% of the people who watch HBO are women. It's saying when we surveyed them, 40% of the men in the entire population said, "Yep, I watch it," and 35 said yes. So this is okay that these two numbers didn't add up to be a total, because basically what this is saying is that when we surveyed, 60% of men said no, and of the people we surveyed, 65% of women said no. Alright, last thing we're going to do today, we're going to do the box plot, which basically is, or not a box plot, a stem plot, which basically we're going to organize our data a little bit. So let's just do the men in what we consider a box plot. So we're going to have 8, 9, 10, and 11, and just to speed ahead, or that's all we need for the men and the women. For the men, when we have 80, the stem is the 0 comes at the end to go with the 8 to make 80, and then also in the 8 column we have 85. So we put 85 down there. 90, we have a 90 over here. 102 and 102, so I have to put down each two separately, and then 109 is in the same column. 115 goes on the bottom there. And then for this one we have, so that would be the men. And I'll make a key that says 8/0 equals 80, so everyone knows what we're talking about. And we want to put somewhere the title of this, we have IQ test. So for the women, now we're going to make this a back-to-back stem and plot. And so I got 90, 100, 100, 103, 110, and 119. Now, this is a good way when it's back-to-back to compare things. We can also kind of look at the center. So it looks like the center is somewhere in the low 100s here for each of the groups. And it looks like the women did a little bit better than the men did on this particular test. There's one last thing real briefly that I want to do here, which is how do we split up, how do we do a split stem plot? So let's say we're given a bunch of data, and I'm going to put 8, 8, and 9. Now 0 through 4 is going to go in the first set of 8s, and 5 through 9. So we can basically split them up by 5s or by 2s. So we have 80 and 80, so 0, 0, 81, 82, 83, 85, 86, 88, 89, 89, and 90. And the reason why we would ever split our stems, we would do this from 0 to 4. If there was a 95 out here, we would have put that down here. But the reason why we split our stems is sometimes we don't want the numbers to go too long. Since I have limited space, I probably wouldn't have gotten all these numbers up here anyway. But this sort of makes it so that we don't go too long. Alright, that is it for the first lesson.